Okay, some core further maths. Got a method of differences question here. The B2 June 2024. Question 3, we've got to split that up into partial fractions and then use the method of differences, show that the sum of it up to n terms is that. I'm going to find out what the P and the Q are and then work out what this is using the part B. So partial fractions first of all. So we write it as something over n plus 3 plus something over n plus 5, multiplying through by this denominator, the n plus 3, n plus 5. Get this. Easiest way to do it, just sub in n is equal to minus 5. So this term goes to have b times minus 2 here, giving you b is minus a half. And when you put n is minus 3, this term goes, you have a times 2, so 2a1, so a is equal to a half. So the two partial fractions look like this. Rather than have a half on the top, I'll just put the 2 on the bottom. And it says, using the method of differences, show that for all positive integer values of n, the sum of the terms is equal to this. And now they give you the partial fractions, they give you in terms of n, but we want r's really. I think it's a bit naughty. I think they're trying to confuse you, get your r's and your n's mixed up. So we don't really want n's. So I'll rewrite this with r's instead of n's, because this is what I want to put into partial fractions, because that's what I've got here. So I'm going to put r is 1 into this. I'm really going to put r is 1 into this rather than this, because I'm going to use part A. So 2 lots of 4 minus 2 lots of 6 on the bottom. And then when r is 2, it'll be 1 over 2 lots of 5 minus 1 over 2 lots of 7. R is 3. I'll do the first 3 terms. I think you should do at least 3, just so you can see what's going on. And I'm not doing any more though, but I'm going to do the last 3 terms. So the third term from the end, the n minus 2. So that will be 2 lots of n plus 1 and 2 lots of n plus 3. And because the 4, 5, 6, the numbers just go up 1 each time, so then it's going to be n plus 2, then n plus 3 goes to n plus 4. And then when I put n in, it'll just be n plus 3 and n plus 5 on the bottom. So that's really the sum of the series. First n terms, I'll put r is 1 right up to n. I'm going to add them together because these right hand sides are all negative. So these 2 terms will cancel out. And all these terms on the right side will sort of cancel out. And down at the bottom, this will cancel out with this one and the one above it as well. So all these terms will cancel out. I'll just be left with just those 2 terms at the top on the left. So 1 over 8 plus 1 over 10, and then these 2 on the bottom, minus 1 over 2 n plus 4 minus 1 over 2 n plus 5. I'll change that into 9 over 40 because I don't know too much faffing about. I need a common denominator because I want it in this term, and they've sort of given me a clue as what the common denominator is because they've given me the answer. So there's my common denominator. So I've got 9 over 40. So my first term is going to be 9 times n plus 4, n plus 5. This one, I just need an n plus 5 and a 20 on the top. And this one, I'm going to need a 20 and an n plus 4. And I've got minus, of course. There's my fraction. I'm just going to sort of simplify it down to this form. Hopefully the constants will go, because there's no constant term at the top. I've really got pn squared and q times n, but no number at the end. When I multiply the brackets out, so I'll multiply the bracket out and multiply by 9, I get this. This one gives me this. This one gives me 20n minus 80, and I've got 180 minus 100 minus 80. Whoop-de-doo. Constant terms cancel. So I've got 9n squared, and then I've got 81n minus 20n, so plus 41n on the top. And I want it in that form, so I'll take an n out as a factor on the top line and write it like that. Then it says use the answer to part B, which was this. Determine a simplified fraction, the value of 1 over 9 times 11 plus 1 over 10 times 12, 1 over 24 times 26. And the difference in these numbers, 9, 11, 10, 12, is 2, like the series I've just worked out. So it's going to be a load of terms like this. And this first term here, I've got r is equal to 6. So I put 6 in here for r. I've got 9 and 11. Then we've got r is 7. And this last one, r is 21. 24 there, I want to put r is 21. So really this is just the sum from 6 to 21 of all those terms. Now I know the sum from 1 to n is equal to this, so I'm going to write it as the sum of 1 to 21 of my series, but I don't want the first 5 terms. I want to start at 6, so I'm going to subtract the sum from 1 to 5, and then I can sub my 21 and 5 into this to work out what the total is. So that's the sum to 21 terms. The n is 21, and this is the sum to 5 terms. Whacking it in the calculator, and I get 192,925.